So in the last videos, I think we are discussing about n queens problem. Okay, n queens problem. So I think yesterday, so in this n queens problem, we defined totally three functions to solve this problem. What is the first one here? We have is safe. That means if you are trying to place a queen, is it the exact position or not? It is going to check. If this function is returning true, happily we can able to place that queen in that position. That is the conclusion. Suppose if this function is returning false, we can't place that queen in that position. That is nothing but the conclusion. This is the main function what we have. Next, n queens. So it is taking a list and then a row value. In this list, it is a matrix style. Suppose if you are giving input as n is equal to 4, 4 by 4 chessboard will be created. In that, every value is by default given with capital X, which indicates that it is a empty position. We are going to check is the solution got or not. How you can able to check if the row value is reached to length of the list, we came to the solution. Then we are printing that board. Otherwise, we are checking in the first row. So total how many columns will be there? N columns. In all these columns, we are going to check the probability. If a safe function is returning true, we can able to place that queen and you can go for next row. So like that, we are keep on checking. Suppose consider in a row, if you have 4 columns, for all these 4 columns, if a safe function is going to return false, then what is the meaning? We can't able to place that queen, right? Immediately, we are going to call backtracking. So that means in previous place, whatever value that you kept, in that place, I'm going to take X. Means what? Something like backtracking. That is not the correct solution. We are looking for another solution. By replacing that queen with X, we will go for another combination. Like that, it is a recursive process. After that, even we discussed about the print board. What is this print board function is going to do? So in the list already we have n rows, n columns will be there, right? That values we are going to print. Up to this we covered the last video. Now we have to fill this safe function. What are the arguments for this safe function? It is taking 3 arguments. The first argument is nothing but that matrix. I can say it is a board. And the second argument is nothing but what? Row value. And the third argument is nothing but what? Column. So based on this, we have to decide. So to understand in a practical manner, just I am going to take one example. You can see here. Consider I have a 4 by 4 chessboard is there, something like this. Or else I will go with, for easy understanding purpose, I am taking 8 by 8. Sir, please focus on this. So 0th row, first row, second row, third row, fourth row, fifth row, sixth row, seventh row, and eighth row. And if you perform count operation 0th row, this will become first, second, so third, fourth, fifth, sixth, seventh. Oh, unfortunately, one extra we got. Okay, no problem. Oh, we can't delete. Like this we have. Now this is 0th column. This is the first column. This is the second column. This is the third column, fourth column, fifth column, sixth column, and seventh column. Like this we have. So in these places, we have to place the queen. Sir, it is a very simple. Just observe carefully. I am going to explain with examples. Consider here, I want to take a queen in this particular position. In which location? Maybe consider here I want to take. Where we need to check possibilities, you have to check in this direction, you have to check in this direction, you have to check in this direction, we have to check in this direction, and this direction you have to verify. Even this direction we have to check, this direction we have to verify, this direction we have to verify. Total how many cases we are going to get? 1 2 3 4 5 6 7 8 cases will be there. By using some elimination method, I'm going to remove some cases. But what is that elimination method? I will explain. But as of now, so what this is a safe function or safe function is doing? Is it clear for you people? Please confirm.
Yes.
Clear, right?
Yes.
Right. Now from this I am going to eliminate some cases. So you have to respond. Please confirm. Suppose consider I want to take a queen. I want to take a queen here. So if you are trying to take a queen here, can I remove this previous place? Why? Because if you are trying to place any queen, so in this particular position, definitely before this there won't be any queen. Even after this there won't be any queen, right? Because we are going to check in every place. So at a time you can able to take only one queen in a row. Okay, you can able to take only one queen in a row. Okay, so 1 second, sir, please wait. Please wait, sir. Yeah, right. Sorry for the delay. Now you can see. So we are not placing any queen before this, and even we are not placing any queen after this. That's why we can eliminate those two conditions. And if you observe logically, when you are trying to place a queen in third row, we are not going to have any queens in the fourth row. I mean, in this diagonal position, so there won't be any queen. And even here also there won't be any queen, and even here also there won't be any queen, right? So here if you observe, these cases we can eliminate it, because when you are trying to place a queen at a third row, there won't be any queen in the fourth row, fifth row, sixth row, seventh row. We can eliminate all these cases. We are not required to check. Only these three cases we have to verify. So the first case I am giving title as vertical up. Vertical up in the sense, from this third location to fourth location, do you have any queen in this particular column? We have to check. And the second one is diagonal left up I am taking. So diagonal left up in the sense, in this position is there any queen? Then so diagonal right up I am taking. That means, is there any queen in this position or not? We are checking. Like this, total how many conditions we have to verify? Three conditions we have to check. So if the concept is clear, I will go for explaining these three cases. Please confirm, is it clear up to this whatever I covered?
Yes, sir.
Right. So next, so I'm going to write code for the first case. So to get more clarity, I'm going to take the queen. Okay, I'm going to take the queen here. So see what are the possible ways are there. Consider I am taking a queen here. Now we have to verify, is there any queen in this direction? Means what is the collision is going to be happened or not? We have to check, right? That's why. So if you observe, what is the location of a present queen? Can I say is it a fifth row comma fourth column? Like this we have. Where we need to check? So 4 comma 4. Sir, where we have to check next? So 3 comma 4. Next 2 comma 4, next 1 comma 4, next 0 comma 4. If you observe, the column values are constant, but row values are decreased by -1. Based on this condition, I'm going to write the code. Okay. Sir, just give me 1 minute. Please wait, sir. I will be back. Please wait. Yeah, right. Let me complete. Sir, am I audible?
Yes, sir.
Right. So you can see here, when you are trying to place a queen here, you need to verify in vertical up direction, is there any queen or not? How you can do that? Actually, this queen is available in 5, 4 position. I'm writing the coordinates. And if we are keep on decreasing the value of row and keeping column value as a constant, we can able to find whether a queen is there or not. For that, I am writing the code here. I am taking I value is equal to row minus 1, because if we are passing the row value as a 5, because it is there in 5th row, so already queen is there. From 4th row we have to check. That's why I is equal to row minus 1. Okay, no need to take any j value because it is fixed, right? Until the value of I is greater than or equal to 0, I am going to check in ith row and jth column. Jth column in the sense it is fixed, that's why I am taking column value. In this place, if a queen is there, then what we have to do? We need to return false. Suppose if it is not there, then take I is equal to I minus 1 and check in its previous position. Okay, like every time we are going to check. This is nothing but it is going to return false when there is a queen. If there is no queen, it won't return anything. At last, we are going to return true. So first we are verifying vertical up direction. If it is not written in any false, then there is no queen in the vertical up. Similarly, we have to check diagonal left up, and similarly we have to check diagonal right up. If all these three conditions are false, that means there is no queen, then immediately we are going to return true, saying it is the safest place. Sir, please confirm, is this first case vertical up? How we are checking? Is it clear? Yes, please confirm everyone. Yes, Bharat, Deepak,
Yes, sir.
please.
Yes, yes, sir.
Right. So similarly, I'm changing the color, and please have a look once. I will remove this, and just I am changing the color. Now I need to check vertical, okay, vertical or diagonal left up. In this place, is there any queen or not? We have to check. What is this coordinates? Is it 5, 4, right? What about the next coordinates? If you check, what is this coordinate? It is nothing but 4, 3. 4, 3. So what is this coordinate? 3, 2. Okay. So next, what is this coordinate? 2, 1. And what about this coordinate? It is nothing but 1, 0. So now you have to decrease the column values by 1 unit, and you have to decrease the row values by 1 unit. Like that, we have to write it. Let us design that. Here, compulsory, we have to take both I and j. What is I value? Row minus 1. What is the j value? Column minus 1. So until the value of I greater than 0 and until the value of j greater than 0, I value is greater than 0 and j value is greater than 0. If both the conditions are true, then we are checking in L of ij, is there any queen or not? If any queen is there, I am going to return false. Okay, so if the queen is not there, then what we have to do? You have to change the value, like I is equal to I minus 1 and j is equal to j minus 1. Like that we have to take. Okay, we are taking I is equal to row minus 1, j is equal to column minus 1. Both are greater than or equal to 0 or not, I am checking. So if both are greater than or equal to 0, we are verifying in L of ij, is there any queen or not? If any queen is there, we are going to return false. Otherwise, we will go for the next iteration. Like that, we are going to check. Please confirm, is this a diagonal left up condition? Is it clear?
Yes, sir.
Yes.
Right. So similarly, we have to check diagonal right up. So what will be the values? If you see the diagram, here we have to verify. So this coordinate, what is its value? Actual, the main value is nothing but 5, 4. Queen is available. Then what about this location? It is 4, 5. 4 comma 5. What about the next location? This one 3 comma 6, 3 comma 6. And what about the next location? It is nothing but 2 comma 7, 2 comma 7, like that we have. And if you write the code, you can see, so the value of I is equal to, I am going to take row minus 1, row minus 1, correct, right? And if you take j value, it is nothing but a column plus 1, column plus 1. Why? Because you can see how we are getting these values. Sir, 4 plus 1, 5 plus 1, 6 plus 1, and here 5 minus 1, 4 minus 1, 3 minus 1, like that. And here I is equal to row minus 1, j is equal to column, okay, column plus 1, until the value of I is greater than or equal to 0, and until the value of j is less than length of the list. These two conditions I am verifying. If these two conditions are satisfied, then I am taking L of ij is equal to yes. If there is a queen, then immediately we have to return false. So otherwise what we are doing, I is equal to I minus 1 I am taking, j is equal to j plus 1 I am taking. Like that we are going to do. So if anywhere in this particular red color line, if there is anywhere queen is there, then immediately we are going to change that value. Otherwise we are not going to do. That's all, sir. This is nothing but the total function what we have. Sir, please confirm, is these three cases how we implemented? Is it clear for you people?
Yes, sir.
Right. So now let us go for, okay, let us go for execution of this particular program, and you can see so how we are going to get the output. Since we are working with n by n, the value of n which I have given is 4. So py space test dot py, you can see it is printing like this. I think we didn't call that n queens, so print board is not required. I am calling n queens by passing the value of list, and then list is nothing but L. From which row we have to start printing? From 0th row. Now what will happen? You can verify. Sir, this is the first solution for 4 by 4 matrix, for 4 by 4 chessboard. And this is the second solution. I think in the yesterday's class, I explained very clearly about these things. Okay. So please confirm, is this solution is clear for you people?
Sir.
If you take n value as a 5, then what will happen? So it is going to give how many solutions? Multiple solutions will be there for this. This is the first solution, this is the second solution, third solution, like that. If you want to count how many solutions are there, we can write a small logic here. What is that logic here? Is count is equal to initially 0, and after completion of these we can print, so number of solutions, number of solutions is nothing but I am printing the value of c. And where it will start, wherever the condition is satisfied, like whenever the row value and length is equal. This is the solution, right? Once if you are getting the solution, I am going to take c is equal to c plus 1. And please make sure, since it is a functional programming, it will take local value. That's why you need to declare manually saying, so global c. That means what? It is going to take the global value and it will print. Now you can see. So total how many solutions we are getting for these? 10 solutions. So this is the way how you can provide implementation for which problem? N queens problem. So when the value of n is equal to 4, how many solutions we got? And when value of n is equal to 5, so 10 solutions. If you want 8 queens problem, just you have to take the value of n is equal to 8. I think more number of solutions you are going to get for this problem. If you want, you can check how many solutions we are getting. 92 solutions we are going to get. Okay. So please confirm everyone, is the concept of this n queens problem and how we solved this by using backtrack. Is it clear?
Sir.
Yes, I request everyone to please confirm. Clear up to this? Right. Anyway, so with this, I'm going to stop today's session. that Sudoku problem is there. It is somewhat lengthy problem. Okay, so we will continue on Tuesday. So tomorrow there is no class. Even Saturday, Sunday, Monday, these 3 days we don't have any class. From Monday we will continue the remaining things. Okay, right, sir. Monday, as usual, you have to join at 7 o'clock. So thank you. See you on Monday. Sorry, Tuesday. Yeah, thank you. You can leave the session.